ounce jar of mayonnaise. Parallelogram. The area is 36. This is the length. This is the height. Area of a parallelogram is length times height. So let's find the x in this equation and get 4.40. Okay, World Grand Speed Record set by Andy Green. Green driving cars at 663.05 miles per hour. How long would it take to travel 1 mile? That means that they're pretty close to square root of this value, that negative. Take the square root of this value, you get 144. So since they're so close to each other, the product is that. You Multiply it by negative 7.2 like it's an error in this equation right here. Yeah, alternative is that divided by anyway, that's what got that wrong. We got the thing that were probably don't count yourself off for that. Jenny hand paints an 8-foot section of fence in 1.1 hours, but it takes her 13 minutes to spray paint it. She started painting a fence, but at some point gave up and swapped with spray painting, cleaning the entire top in 10 hours. What practice is hand painting? So, we'll say we'll find X, the value of the amount of time she spent hand painting. So, the rate for hand painting is 1.1 hours. That's multiplied by some time. Then her spray paint rate is 8 over 13 minutes hours. As seen here. And anytime she's not hand painting, she's spray painting. So that's equivalent to 10 hours minus the amount she spent normal painting. And all that will combine to 147 cents being done. Then once you have that time, around like 7.5 hours or so, you quickly put it back into the rate equation to figure out how much divided by the entire thing, multiplied by the rate. Do that, you get 37. First off, we have a brushless program for this. Plug in the two radiuses, which are these numbers divided by 2, and then the height of 11. Alternatively, you could just use the equation for brushless. I'm using the radius here and dividing by 2 to counteract that. X divided by 2 is all squared, X squared then over to the second part of the equation. Multiply by 5, multiply by 5. And then you have to divide by 8 hours to find the rate of 0.157 inches cubed per hour. Okay, 29, a sphere. What the surface area of a sphere is 4 pi r squared. So r squared times 4 pi. You get 4.23. Multiply by your unknown length, or whatever you want to call it. That'll get you a volume of 0.0285. With that, you get a value of 4 miles, so let's convert that to feet. And then let's convert the speed to feet per second, because that's what everything's kind of based on. So feet per second, miles per hour. hour skid when the centrifugal force is 600 lbf. What is the turning radius to initiate the skid? And then it gives you this conversion right here. So let's convert this LBM to the LBF that's used in the force. To do that, you get 108.78. Measuring how far it's moving in radians. We have to divide it by the radius here after converting from feet to feet per second. That's being used here. So yeah, you do that and then you square it. So that's what the equation says. Now this can be positive and negative, and you're going to have to use it for both, the positive or negative. And then you find the intersection y and x sides. Represents half of the amount of the circle covered, so 90 times 2, 180 degrees of circle covered, which is half this. That's why the diameter is the hypotenuse. So, now we have that. Use the triangle program, do that. And then you will get a value here, or an x value here of, let me just check what you should be getting. How many 8-foot long beach towels are needed to cover the same area? Area is side squared. Has 25 5-foot bath towels. Those towels have similar shape and can be 8-foot long bath towels want to cover 8 over 5 squared times the area. Because area is side squared. Basically, you're doing 8 squared over 5 squared times the area. Clearly, you're going to need less towels that are bigger. So divide it by 8 over 5 squared. And then you have to round up because you can't have any less than what you need. So you get 10 towels. y1, y of 1 plus the last x. Actually, yeah, you do need to make a positive guess if you wanted to solve it, you know. But other than that, not much you have to do. 49 is a bit of an interesting one. This is going to be a three-dimensional line. So we figure out the change of height. Then you need to figure out this, which is a little bit more complicated. So you see how the end of the is given in case you didn't see that they're identical rectangular solids. So as you can see, this smallest section here is 0.2. For that value, you take the square root of all that added together, and you get 0.977. So, you have a cylinder and a cone. The volume of a cone is 1/3 the volume of the cylinder. If you understand cones involved, they don't give you a volume or value that seems like you very clearly need. You can generally assume it doesn't matter. So if you do that, then you can assume the radius is equal to 1. So area of a cylinder, r squared times pi times height, multiplied by a third, because that's what the equation says. 1 squared times pi times x over 3. And as you can clearly see, x is just going to be equal to 3 again. The sixth was the area between the curve negative 3x squared plus 9 of the x-axis. Make sure to put this equation into y1, but y2 is equal to 0 because you're looking for the x-axis. Then you can use our auxiliary program. Auxiliary, no input, it'll get the input just fine. A line of revolution is not relevant, and you're just looking for the area under the curve of 20.8. 57. This is going to be pretty hard to explain, but I'll try my best. Farmer constructs a pen of constant area A, using as little fencing as possible. The shape of the pen looks like that, a rectangle with a semicircle at the end. Now, what is the ratio of the rectangle side dimensions that minimizes the perimeter and number greater than 1? Well, hopefully maybe I'll try to explain as best I can, but the point at which the perimeter is the minimum has the same side dimensions as the point where the area is maximum. If you're looking to increase if you can imagine like the maximum area at a given point, the perimeter, if you have a bigger perimeter, you can get that area that you're talking about, but you need more perimeter to do it. The area maximum for a given perimeter is equal to the perimeter minimum in terms of size proportions. So, now that you have that, we can use our more easily understandable equation. We can basically say let's say the entire perimeter is 1. So first off, we're going to say the perimeter on the width essentially is x. But the perimeter spent on the width. So x over 2 gives you one side of the times the rectangle. And that's times the height, which is the entire one perimeter that's not being spent on x. Is being spent on the other portion, so 1 minus x. And then you have to divide it to get by the appropriate amount to get one side. Well, there's 1 here, side here, and this is a half of a circle. So it'd be pi equals a full circle. However, since it's half a circle, it's pi over 2. Then we're assuming this side is 1 in this case scenario. And then in this case, once you do that, that will get you the area of the rectangle. However, you also have to figure out the area of the semicircle. So the same rectangle side length we saw, dividing by the same stuff. And then you have to divide by 2 to get the radius. Square it, multiply by pi, and divide by 2 to find the area of your semicircle. And if you do all that, you will get an x value that represents the amount of the perimeter spent on this. You're still not done. You got to figure out the side dimensions from that x value. So the side dimensions of the width, as we talked about, are going to be x over 2. And then the height, as we did before, is going to be the entire one perimeter that's not spent on x divided by the same formula to get to the length of the side. If you do that, you'll get a value of 0.5. Once a ratio that's greater than 1, so you have to inverse it to get 2.00. Very hard problem like that. You should be proud of yourself if you got it. What it is the sum of the determinants plus here is equal to 3. Actually, I never said why the derivative is equal to 0. The perimeter minimum is when the derivative is equal to 0. So that's why you need to do the derivative equal to 0. Because that would happen at the perimeter minimum and area maximum. Solver, and you can actually just press alpha F3 to create your own matrix. They just plug in your unknown value for it. And then matrix becomes math determinant for the time level determinant. Do all that, you get a value of -1300. First phase takes this too much time. 59, and you're getting the speed area of equal. Figure out where this is. This is the orthogonal position, but it's okay. But this is y1, and you'll find that it's equal to 0 at x equals 1. Now you need to figure out what is the area of the segment for this area of the curve. So integral from 0 to 1 of that equation gets you as -0.0833, etc. If they don't care about positive or negative, you have to figure out when you integral from 1 to your unknown x value, and that equation is equal to positive that value. Because the areas are equal, this has to be also be 0.08333. The integral from 1 to that equation is equal to 0.0833. Then you EQ solver for z, which is going to be the upper bound that we're looking for, and you get 1.33. Okay, next thing, squares and 4 identical rectangles. Small square value, which is this, is equal to 1/2 the large square value. So let's write an equation for that. So small square side squared is equal to 1/2 the larger side squared. Once you have that x value, you see that this unknown side is equal to that x value plus this segment right here, which we need to find. Well, if you subtract 4,850 by x, or x by that value, you'll get 2 of these segments left, and dividing by 2, you'll be left with 1. right 50 minus x over 2 gives you that smaller segment, and then plus the x you already have. Gives you a value of 4,140. Okay, 61 is going to be your sine program. You have a sine totally changing thing with a maximum of 1.3, a low of 76.5, and 12 hours later the period is 2 times that of 24. So sine is an undercurrent program. We know our y, because we're 86 degrees. We know our y, put in the lower value, put in your higher value, put in your period, and put in your unknown y. So, and then you're looking for, because hopefully you know 76, 85, and 123, time period is going to be on to the lower of the two you get. However, there's a cap. That the time period you're given is the difference between the first 86 degrees and the second 86 degrees. However, we're looking for the time between the minimum and 86 degrees. So if you can kind of imagine like this. As you can see, the distance from here to here in terms of x is half the distance from here to here. So you divide the time by 2, and you get 5.10 hours. 62. The odds of winning the Texas Powerball are 1 in 25,827,165. Was a number raised to the 27,600th power. So we have our overfund F problem or program. This is going to be an underflow. This number is clearly going to be much less than 1. Your base is going to be 1 over that value. And your exponent is going to be 27600. And then once you do that, you get a value of 4.81 times 10 power to the negative 204,574. Dirk throws a penny off the top of the Texas State Capitol building, velocity is 28 miles per hour, leading angle 64 degrees. It's ground in 5.63 seconds. What is the Capitol elevation? Unfortunately, we do not have a kinematics program for 1D that does not take a y value. We may be able to actually, can we use Kenny? So you're given. You would need x naught. So, in this case, we'll have to do it ourselves. The equation for distance is acceleration over 2x squared plus velocity x plus your solid velocity. So, we need to figure out the vertical speed. That's all that really matters is capital elevation. So you have to take your sine of the speed. Divided by 2, multiplied by x squared, and the next value of 5.63. Do that and look for y1 at this time period you're given. You'll get negative 302, which clearly shows that Capitol is 302 feet tall. 64. Who's ready for a really, really long EQ solver problem? Technically, you could probably assume the radius is 1, then use log sine, or then use our our SAS program here to figure out this side and then take the proportion and all that. Or you can make the biggest EQ solver problem in the world. We need to figure out what this radius is. We need to do that by law of cosines. This angle right here is going to be the entire 180 degrees minus these two angles. Then we have to figure out, and we know that these sides can be found based on R. So we need a humongous EQ solver problem. So, equation for law of cosine, square root of one side squared, which is going to be x, your unknown radius, times cosine of 42.7 power to negative 1, because you need to go from adjacent to hypotenuse. To do that, that gets you this side right here, squared, plus the other side squared, which is done by the same method, minus 2 times one side, times another side, times cosine of your angle. And that value has to get you 0.924. To do that, you get an R value of 0.441. Okay, you're given an infinite number of squares. Some of the square perimeters is 3,520, and each side length is 1/2 of the previous side length. So the perimeter is 4 times the side length. So the perimeter is basically, if you assume the side starts at 1, it's 4 plus 2 plus 1 plus 0.5, etc. So that's a geometric series. So sum of the geometric series is your starting value over 1 minus your ratio. So in other words, you're multiplying by 2 times the starting perimeter. Well, that means that 2 times the starting perimeter is 3,520. Your starting perimeter is that value divided by 2. Then you divide by 4 to get one side. Hopefully Sawyer can stop barking, but that's basically the entire test. This is probably the hardest test from this year, in my humble opinion. There's a lot of complicated stuff on it. And if you have any questions, please leave a comment and I'll try to answer them, or ask me in person.